All right, welcome. Today, we're peeling back the curtain on the internet itself. We tend to think of it as this simple utility, kind of like water or electricity. But the reality is, well, it's way more complex and honestly, a lot more interesting. So let's just jump in with a pretty wild idea. What if the global network we all rely on every single day isn't a utility at all? What if it's actually a massive, real-time game where giant players are constantly making strategic moves to get an edge? That's exactly what we're going to dig into right now. So, who are the players and what are the rules of this game? Let's find out. Right, so every game's got players and it's got rules. First things first, let's figure out who's actually at the table and what rulebook they're all forced to follow. Okay, so the players in this game, they have a name, autonomous systems, or just ASs for short. The easiest way to think about an AS is as a huge, distinct piece of the internet, with its own rules and its own agenda, all controlled by a single organization. And look, we are not talking about small-time players here. We're talking about your huge internet service providers like Comcast or Verizon. We're talking about massive university networks, giant tech companies like Google and Amazon, and yep, even government agencies. Every single one of them is an AS, a player in the game. So, what's the rulebook for this whole thing? It's a protocol called the Border Gateway Protocol, or BGP. This is the absolute bedrock. It's the set of rules that lets all these different autonomous systems communicate and figure out how to shuttle data across the enormous tangled web of the internet. And this right here is the key idea you need to grasp. There's no central planer. There's no puppet master deciding the most efficient way for data to travel. The entire global map of internet traffic is built from the ground up by countless, individual, self-interested decisions made by each and every player. Okay, so we've got our players, we've got the rules. Now let's get into the action. How is this game actually played? What's the core mechanic that makes the whole thing tick, or, as we'll see, sometimes break down? So the core mechanic comes straight out of game theory, and it's called best reply dynamics. Now, it sounds a little academic, but the idea is actually super simple. Each player is constantly looking at what everybody else is doing and asking one simple question. Given what they're all doing right now, what's the absolute best move for me? So what does a turn even look like in this game? Well, it's this constant loop. First, an AS looks at the data routes its neighbors are using. Second, it checks that against its own internal rulebook. What's going to be cheapest for me? What's going to be fastest? Third, it picks the best path for itself. And finally, it shouts out to its neighbors, hey everyone, I'm using this new path now. And the whole cycle just starts all over again. So you see, every single AS is making what we'd call a greedy decision. It's a lot like being at the grocery store. You pick the checkout line that looks shortest for you, right? You don't really think about what would make the checkout process for the entire store more efficient. Now multiply that selfish logic by thousands of massive networks, and that's how you get the internet. Now, when this all works out, when everyone finds their best move and things settle down, the system converges, and we get a stable, working internet. But what happens if the game never ends? What happens if the players just keep changing their minds over and over forever? And that question brings us to the dark side of all this. What happens when the game breaks? When all this selfish but rational playing just leads to total chaos? Yeah, there's a name for this kind of failure, and it's called a dispute wheel. And it is a total nightmare scenario. It's a situation where the player's preferences create a paradox, a cycle where no stable outcome is ever possible. It just leads to endless, chaotic oscillations that can literally break parts of the internet. All right, let's actually build one right now. It's simpler than you might think. Imagine player 1, or AS1, looks at all its options and decides its best path to send data is through AS2. Simple enough, right? But AS2 then makes its own greedy choice. It looks at its options and decides, nope, my best path is actually through AS3. So now the data is flowing from 1 to 2 and then on to 3. And here is the twist. AS3 looks at its options and decides its most preferred route is, you guessed it, back through AS1. And just like that, we've created this impossible closed loop. 1 wants 2, 2 wants 3, and 3 wants 1. So where does the data go? The answer? Absolutely nowhere. It's trapped. The route announcements from these players will just flap back and forth forever, creating a kind of digital black hole. all caused by perfectly rational but conflicting self-interest. This whole mess, this potential for total breakdown, it leads us to a really fundamental question about the economics of the internet. In a game like this, does it even pay to be honest? Is being truthful and following the rules the actual winning strategy? Okay, so there's a formal name for this concept: incentive compatibility. All it really means is designing a system where being honest, where acting truthfully according to the rules, is also your single best personal strategy. It's a system where honesty is automatically rewarded. And this is the real punchline. The Border Gateway Protocol, the system that makes the entire internet run, it is not inherently incentive compatible. Sometimes players can actually get a better outcome for themselves by lying or by not playing the simple best reply strategy. And what that means is we have this fundamental trade-off, this conflict at the very heart of the network. On one side, you have the dream, a perfectly efficient internet for everyone, what economists call optimal social welfare. And on the other side, you have the reality, the best, stable outcome you can get when you know all the players are just acting in their own self-interest. And these two things, they are very often not the same. And listen, this isn't just me talking. The research this is all based on puts it bluntly. Incentive compatibility can be costly. What that means is building a system where everyone is incentivized to tell the truth might mean we have to give up on the idea of having the absolute fastest, most efficient network possible. So here's the bottom line. We are constantly faced with a choice. We can either design a perfect internet on paper, one that's beautifully efficient but would probably fall apart in the real world, or we can design an internet that actually works, one that is stable and robust, precisely because it takes into account that every single player is just playing to win for themselves. And that leaves us with a huge, looming question for the future. As we design the next generation of global networks, for everything, for AI, for finance, you name it, how on earth do we write the rules for a game when we know from the very start that every single player is playing to win?